Okay, so hello again. Um, right now, we're going to continue answering these exercises, and I'm going to help you solving the next exercise. So, first, we need to stop and analyze and read carefully the instructions for this question. We need to find the slope of the tangent line to the curve y equals x minus x to the third. So this is not a parabola. This is a curve, a different curve. And we know that this is a third degree function. So we are going to learn and remember how to graph these functions. We have to find the slope of the tangent line at this point, at 1, 0. So that is x equals 1 and y equals 0. Then we need to find the equation of the tangent line and we need to graph both functions. So as you saw on the last video, we did all of the steps in order to find this information. So for this exercise, I'm going to go a little bit faster. Okay? So step number 1, we need to find the derivative. So that will be y prime is equal, so we're going to use the definition. So the definition is limit when h is approaching 0 of f of a plus h. So that means for every x we write a plus h. So that will be a plus h minus a plus h to the third power. And then we're going to write the second part of our definition. So let me make this longer. I recommend you to write the second part inside a parenthesis. So then we can change all of the signs of all of the terms after this negative sign. Okay? So for every x we write an a minus a to the third over h. Okay, so we are going to develop this sum. We're going to raise this sum of two terms to the third power. We're going to change all of the signs of this expression and we can remove this parenthesis. So this is the limit when h is approaching 0. We draw another horizontal line for the fraction, for the division. And this is going to be a little bit longer. So a plus h minus, and then I'm going to change all of the signs on the same step. Minus a to the third minus 3 times a squared h minus 3ah squared, and then I change the sign for this other part, minus a plus a to the third over h. Remember, let me draw that again. Okay, so remember, we're going to cancel out some of the terms, but we need to remember that we are canceling the leading term or the term with the highest exponent for a and other terms. So for this case, we cancel a to the third negative, a to the third positive. We also cancel this a and negative a. And we have to check that the terms that are left, they have at least one h that we can factor out. Okay, so let me rewrite this again, and on the same step I'm going to factor out the h. So I'm going to rewrite and factor. I factor only one h. That's the only thing I can do. So I'm left with the number 1 here minus 3a squared minus 3ah minus h squared over h. So this is the most important part of this process, to cancel the h. If I'm not canceling out this h, that means that something is wrong. Let me draw that equal sign again. So I'm left with the limit when h is approaching 0 and the fraction is gone. So I write 1 minus 3a squared minus 3ah minus h squared. And this is where I'm going to plug in this h for every term that has an h. So I'm going to plug in here. I'm going to do it here also. So these terms are going to be 0. So they cancel. Now that I have evaluated the limit, I'm going to write the expression 1 minus 3a squared. So this is the derivative in terms of a. I need to write this derivative in terms of x. So this is 1 minus 3x squared. So I need to return to the original variable. Okay, so this is step number 1. I found the derivative. Now, step number 2. Let me show you something. I know that this point passes through this, that this equation or this curve passes through this point. Or in other words, I know that this point belongs to this curve. But I can still check that. If I plug in 1 on the original equation, I'm going to get 0. Okay, so this will be f of 1 that is on the original equation. It will be 1 minus 1 to the third power, that is equal to 0. Okay, so I'm just checking that everything is correct. Now, the next step will be plugging in this value not on the original equation but in our derivative. So we can find a specific slope, the slope of the tangent line that is passing through our given point. So f prime of 1 will be 1 minus 3 times 1 squared. This is easy. So our slope will be -2. Okay, this is our slope. Okay, we have a slope, we have a given point, 1, 0. So with a slope and this given point, we can use our point slope form. So that is y minus y1 is equal to m times x minus x1, where y and x are our variables, y1 and x1 are the values for our coordinate of that point, obviously. So y minus 0 is equal to negative 2 times x, that is our independent variable, minus the value of x1. Now we solve for y, so our equation in the standard form will be minus 2x plus 2. Okay, now we found our equation. That means this is a descending straight line. How can we graph this function? So our last resort is to make a chart with several values for x and y. Then we locate those coordinates and then we just connect the dots. But I think it is better to analyze and find the x and y crosses. So we remember that this equation has a shape of an inverted N, and it will cross the x-axis 3 times. How can we calculate the x-crosses? So for the x-crosses, remember that y is equal to 0. So 0 is equal to x minus x to the third. Now we can factor out a common factor, x times 1 minus x to the second power. This is a difference of two squares. So we can factor this difference of two squares into two factors that are alternating the signs. So 0 is equal to x times 1 minus x, 1 plus x. So now we have three factors that are equal to 0. X equals 0, 1 minus x equals 0, 1 plus x equals 0. So the three values, or the three x crosses, will be x equals 0, x equals 1, and x equals negative 1. Now, we know that our curve is crossing at the origin again at negative 1 and at positive 1. And since this is negative, the leading term is negative, that means it would look like an inverted N. So let me try to draw this graph. So it will come from above, will cross at x equals minus 1, it will cross at the origin, and then it will cross at x equals 1. Let me do it again. So it is crossing here, then it will cross at the origin, and then it will cross here. That is the sketch of my graph, and then I will show you the real graph. So which is my point where we are finding this tangent line at 1, 0, 1 in x, 0 in y, So we need to draw this tangent line. So this is crossing, this is 1, this is 2, so it is crossing the x-axis, the y-axis at 2, that is the independent term. So now we can imagine, or we can figure out, okay, that is not that close. Let me do it again. As I said, this is my first time using this. This is my second time using this tool, so this is a little bit better. So this is a sketch. I could do this better on paper, but you must do something similar in the exam or at class. So now I'm going to show you the real graph so we can compare a sketch and the real graph. So if I show you the real graph, you can see that it is pretty close. So this is our function, an inverted n. This is our point, and this is our tangent line. We know that it is descending because the leading coefficient is negative. So that's it. This is how you find the equation of a tangent line at a given point. So I'm going to continue solving more exercises. Thanks for watching and see you soon.